Hi everyone, in today's tutorial we want to find all the solutions of r in the equation r squared is equal to root of 8r. All the solutions, be they real values or complex values. So let's start. Our equation is r squared is equal to root 8r. We want to solve for all the values of r in the set of real numbers and in the set of complex numbers. The first thing to do is to remove this radical sign here. So to do that, we have to square both sides. Okay, so we have r squared is equal to root 8r squared. So we see that this becomes r to the power 4. This square will cancel that radical sign. We have 8r. Now we should avoid the error to get to this level and say we divide both sides by r. Divide here by r, divide here by r. That is not the right way forward. This will destroy one of the solutions because you see it's a polynomial of degree 4. We are supposed to have 4 solutions here. Okay, so if we do this, we're going to destroy one of the solutions. So the right attitude is to take this 8r from the right hand side to the left hand side. We have r to the power 4 minus 8r is equal to 0. Now we see r is common, we factorize out r. We get r into r cubed minus 8 is equal to 0. Now we have the product of two expressions giving us 0. Either this one is 0, either the first expression is 0, or the second expression is 0. Alright, r equals 0, that simply tells us that 0 is our first solution. Alright, the first solution in the set of real numbers. Now we look at the second one, r cubed minus 8 equals 0. Again, we should not do the error to say we take 8 to the right hand side and then later on we take cube roots of both sides. If we do that, then we will have destroyed two other solutions. Okay, that will just give us just one solution, which will be the value r equals 2. But here we're supposed to have 3 solutions. So what we need to do is to recognize that 8 is actually a cubic value. That means 8 is a number raised to the power 3, which is 2. 8 is 2 cubed. So this is written as r cubed minus 2 cubed is equal to 0. So now we see clearly a difference of 2 cubes on the left hand side. Let's apply the identity of difference of cubes. When we apply that identity here, r is A and 2 is B. Let's follow the identity strictly and write out this. So we're going to have r minus 2 into r squared plus their product 2r plus negative 2 squared, which is 4, equals 0. This expression multiplied to this expression giving us 0 means either the first expression is 0 or the second expression is 0. So we have two equations to solve. Let's start with this first one. R minus 2 equals 0 means that R is equal to 2. This gives us our second solution in the set of real numbers. Okay, we'll now take the OR. R squared plus 2R plus 4 equals 0. This is a quadratic expression in terms of r, so we're expected to have two solutions. Now, what are the factors? Let's use the quadratic formula. Let's collect our coefficients. A is 1, B is 2, C is 4. So we'll use the quadratic formula. R is equals to minus B plus or minus the root of B squared minus 4AC all over 2A. So if we put in our values carefully, we're going to have negative 2 plus minus the root of 2 squared is 4 minus 4 into our A is 1 and our C is 4. All of that divided by 2A. This gives us negative 2 plus or minus the square root 4 minus 16, because 4 multiplied to 4 is 16. 4 minus 16, negative 12 all over 2. All over 2. Now, okay, so we have r equals negative 2 plus minus the root of negative 12 all over 2. But what is negative root of negative 12? Is the root of negative 1 times 12. This is the same as the root of negative 1 multiplied to the root of 12. But the root of 12 can also be written as root of 4 times 3. So all of this gives us root of negative 1 multiplied to root of 4 multiplied to root of 3, which gives us root of negative 1 is the imaginary number I. Root of 4 is 2, and then multiply to root of 3. So root of negative 12 is I 2 root 3. So let us put that in this expression for r. So we say r is equal to negative 2 plus minus I 2 root 3 all over 2. We see 2 is here, is there, and is here, so we can divide all around. So r is equal to negative 1 plus minus I root 3. Okay, now that is it for the solutions of r. So we've gotten all three solutions because our radical equation is actually a polynomial of degree 3 written in a disguised form. So let's just write down all the three solutions again. All three solutions that we got are, we have r equals 0, we have r equals negative 1 plus I root 3, and we have r equals negative 1 minus I root 3. These are our three solutions for the radical equation.